Good morning, AP Statistics. Mr. Anchor here, looking at the 2020 mock exam number 3, written by our textbook authors, Daren, Starnes, and Josh Tabor. Thank you to them. So this was the longer question, 25 minutes. Hope you're timing yourself to practice that timing and get a sense for how long these things might take. Question A, explain the purpose of random assignment. This is a really good question. It's a good question for multiple reasons. But for one reason, we often check the random condition, but we don't always talk about the importance of the random condition. So the purpose of random assignment is to create two groups that are roughly equivalent in their ability to do barbell curls at the beginning of the experiment. This will allow for a cause and effect conclusion if the difference between the two groups is statistically significant. Let's talk about confounding. Oftentimes we can refer to random assignment helps us to address confounding, but you wouldn't want to leave it just at that. That wouldn't be enough for full credit. So let's say that the people who were encouraged, let's say we let people choose what treatment group they're in, and let's say the people who are in the encouraged group, they typically exercise. They know that they need encouragement as they exercise and things like that. So the cause and effect, we'd like to know, being encouraged, that treatment leads to more curls. But this confounding variable, if we don't address that, this confounding variable here, that's actually the reason why they can do more curls, because they're in better shape and they typically already do curls. So we don't want this to happen. So the way to address that, we use random assignment so that the people who typically exercise are equally divided. People who exercise regularly are equally distributed or equally divided into both groups. That's how random assignment is helping. So that kind of, because we have that can address this confounding variable. All right, so that was the first question. Next question. You can be pretty confident that you're going to see a question about comparing or describing distributions. So these are box plots. Definitely want to consider to address all these things, socks, and then plus context. So we have the distribution of number of barbell curls. So we have the context, slightly skewed right for both groups. So we have shape. The median number of curls, context, and the center. The variability or spread of the number of curls is greater. There is comparative language. So make sure you use comparative language. Also note that there's no values, which is completely fine. That can help you speed up your response. Now, if you want to include values, that's not a problem. You could estimate where the median is, where the median is. You could estimate the IQR by doing Q3 minus Q1, and then getting this range and then this range. You could do those things, but it has never been required on a rubric that students have to include numerical values. Something that you don't want to say with Box plots, beware not to say. Box plots cannot be approximately normal. They can't be approximately normal because we can't tell peaks and gaps and things like that from box plots. Don't know where those are. So a box plot, you could very well have a shape that looks like this and get a box plot that might look roughly symmetric, but it's definitely not roughly normal based on the dot plot. This would be a bimodal dot plot and symmetric. And all we can tell from this is that we have a approximately symmetric. So if you see a box plot like that, be careful not to call it approximately normal, but the better term would be approximately symmetric because both of these graphs, the dot plot and the box plot, are symmetric. Letter C, state the hypotheses. This is also a really good guess on the types of questions. Since they're light on calculator calculations, you'll most likely be given questions where you're asked to write hypotheses. This is not paired data. We didn't have one person do the curls with encouragement and then the same person do curls without encouragement in a random order. So we're not going to use one mean of the difference. That would be like a paired t-test. These are two different groups randomly assigned. So here are our hypotheses. And be careful to define the parameter that we have right there. Define the parameter. Make sure you mention the unknown mean or true mean or the population mean number of barbell curls for people like the ones in this experiment who can do encouragement. And then mu n is the people who don't receive encouragement. Notice also it's kind of a future tense. So they can do. So be careful to use future tense or present tense. Avoid past tense. When you're talking about parameters, the reason why we avoid past tense is because we don't want the parameters ever to be like referring to the sample mean or the sample proportion. And if you use past tense, that makes it sound like you're referring to the sample, but the whole point of hypothesis testing is we'd like to know about the unknown or the true mean, the unknown mean, the population mean, not the sample mean. Next question, identify the significance test that would be used. Like I said before, since it's this test this year is lower on the calculations, you should be ready to check conditions, write hypotheses, and identify tests. So earlier I said this is not a paired test, but this would be a two-sample t-test for difference in means. You could also write that in words, just in case you don't know if it's mu or x bar. I would just say mean. But we are testing for the population means, the difference in population means. And then the conditions, you don't want to just do random check, but we have random assignment. Treatments were randomly assigned. It was not a random sample, so random sample check would also be incorrect. So you can check your work if you said random sample check. I think there were volunteers at the beginning. And then for the normal large sample, just to review that quickly, of one of three options, you're told that the population is roughly normal. Your sample size for both is greater than 30. That would be the central limit theorem. Or if your sample sizes are less than 30, we look at a graph of the sample data. You do have to refer to the graph. If there's no graph provided, then you should graph the data yourself. Now we've been told though that on this year's exam, you won't have to graph anything. It's kind of strange, but so you'll be provided a graph and we can just refer to this graph. So neither distribution shows strong skew or outliers. and then the conditions met. You'll notice that there's no independent condition that they checked. The reason why they left off the independent condition is they don't want you to do the 10% condition here. It's not an experiment. We only do the 10% condition with samples, with random samples. Since this is an experiment, we don't do the 10% condition. And rather than trying to state that one group is independent of the other, that wouldn't be a problem to include that. But for this rubric or scoring guide that they created, they just left off the independent condition. So, and that's a safe bet. If it is an experiment, then you don't have to include the independent observations condition. You could also include that the groups are independent. That wouldn't be wrong to include. It'd be good to include. But the thing that you would not want to include is the 10% condition. It would not apply here. And again, we only check the 10% condition when sampling without replacement. Sampling without replacement, which we're not sampling without replacement here. We chose volunteers. And then lastly, E, the p-value for the test was a very large p-value. What would we conclude at a 5% level? The components that you need, you have to explicitly compare the two, alpha to the p-value, so make sure your response has that. You need a statement about the null hypothesis. We fail to reject, we do not reject the null. You need a comment about evidence, so we don't have convincing evidence. And then you need the context and what the alternative hypothesis was. So this is the HA. And maybe while we're here, let's just review interpreting a p-value. That's definitely fair game. So interpreting a p-value, we don't know the actual difference. We're never told the difference in means. So I'll just give you a general template as a quick review. So to interpret the p-value, again, not required here. So we'd say, assuming the mean number of barbell curls is the same for both groups with or without encouragement. There's a, whatever the p-value is, chance we'd get a difference in sample means the direction of the alternative hypothesis was greater than and we don't actually know, we're not told. The difference in sample means this. Just due to random chance. Let's see if I got everything here. Assuming, so we have assuming the null. Check. We have context. I mentioned barbell curls. I mentioned the p-value. We weren't really told this, but we have the direction of the shading. A lot of students just say that we'd get a difference of exactly this, just due to random chance, and forget the direction. So it looks like I got everything. Let me just compare it again to graphically. Whenever we calculate a p-value, so the p-value we had was like 10%. This value here is the difference in sample means that we weren't told. And here's our null. Equals 0. This would be our standard deviation, whatever that is. Standard deviation of x bar e minus x bar n. I guess it would be SE. But when you're interpreting a p-value, you need to mention the p-value, the direction, the statistic or the test statistic, and then the null, which is assumed. So the null, which is assumed, is right here. The test statistic is right here. The direction is right here. And the p-value in context with context is right there with context. So that's interpreting a p-value. That's definitely fair game. I would be prepared not just to conclude a significance test, but also to know how to interpret a p-value. Thanks for watching this video. Feel free to give me a thumbs up if you liked it. And feel free to ask any questions if you have any follow-up questions. I really appreciate hearing from you and helping you prepare for your exam. Have a great day.